everyone. So before we start with the work for today, I just want to go through a bit on the test that's coming up. Okay, remember you got 1 week to prepare. Okay, please do not forget the date. Okay, so the scope for the test will be everything up to and including what we finished today. So at the very beginning on sets, okay, then functions. Remember functions, domain, range, and target. Piecewise functions. Okay, so functions with a different rule on a different part of the domain. Okay, and then here, injective, surjective, and bijective functions, and function inverses. Okay, so that will be for the test. Okay, so the test will be around an hour, hour and a half. Okay, so I do give extra time. Okay, so around that long, and that will be done in the tutorial. Okay. Okay, so please go through all of the homework stuff, the tutorials, and any additional questions that I put up. Okay, remember on Learn, there's that section on additional homework, additional questions. Please make sure you go through all of that as well. Okay, so we're going to go through a quick recap of what we covered last time with injective, surjective, and bijective functions. Then we're going to have a look at a few more examples of finding inverse functions. Okay, remember that is different to what you did in high school. So in high school, you just found what the functional form was. So you swapped the y and the x, you solved for y, and you called that the inverse. Okay, you didn't pay any attention to the domain, range, or target. Okay, so now we're going to do the same thing, find the functional form, but we're also going to look at the domain, range, and target. Okay, so that's the extra stuff that we're going to do. Okay, so firstly, injective. What do we mean by injective? So firstly, it's 1-to-1. So for every x in the domain, it gets mapped to one element in the target. Okay, remember for injective, your target can have more elements than you actually use up, but as long as it's 1-to-1 for the stuff that you do use, it is injective. Okay, so if you want to look at it in terms of a picture, 1-to-1, okay, remember that horizontal line test. If you have one y value and two x values that go to it, then it's not injective. It's many-to-one, so we ignore that. Okay, if you want to test it algebraically, if I give you an f, we can use this statement here to test if it's injective or not. So whatever f I give you, we set f of a equal to f of b. You do, I'll get you now. You do whatever you need to. If you end up with a equals b, it's injective. If you end up with something else, it's not injective. And we did that example with the straight line and showed it was injective. We did the other example with a parabola, and that was not injective. Because we got a equals b, we also got a equals minus b, and that messes things up. Okay, yeah, your question?
Exponential graphs, injective.
Yes. Yeah. So we can do a little sketch on the side here. That is in the tutorial. Did you get it from there? Okay. So exponential, something like this. Okay, there's a number of ways of testing it. So the first way is just looking at it. We can see 1x goes to 1y. Or you can do that horizontal line test, which is equivalent to just looking at it. Okay, we see that it only cuts at one point, so it's injective. Or you could do the other way. Let's say this was f of x equals 2 to the x, 2 to the a equals 2 to the b. Same base, the exponents must be the same. You can do it like that. Or you can take log base 2 on both sides and you'll get a equals b, which is what we need for injectivity. So again, a number of ways to check. Okay, so in the test, if I don't specify do it this way, you can do whatever you want to do. But if I say do it using the rule, then please use the rule. But if I don't specify and you just want to sketch it, and show me from the sketch, that's fine, right? They're all equivalent. Okay, so that's injective. The next thing is surjective. That's also called onto, okay, like we did last time. And the reason we call it onto is because all of the domain is mapped onto all of the target. Remember, we don't leave stuff out with surjective maps. So that's why it's onto. We map the domain onto the whole of the target. And since we do that, the range is equal to the target. So f of x, the entire set x for the domain, is equal to the entire set y. Okay, so if I say show that it is surjective, you can do it that way. You can show that. Okay, writing that in words, we have target equals range. Actually, the other way around, because y is the target, if you want to look at it like that. And then writing the whole statement out in words. For every y in the target, there exists an x in the domain, such that f of x equals y. All of these statements here are equivalent. So you can use any of those to show that it's surjective. Okay, and we showed some examples. So with a straight line, the whole domain R got mapped to the whole range Y. Why? Well, the straight line goes positive and negative infinity, so it covers the whole target. On the other hand, a parabola, if we have the target being all real numbers, it's not surjective, because the parabola just takes up the top plane, not the bottom plane. But if we limit the target to the upper plane, then it does become surjective. So it always depends on the target. Okay. And then bijective, that is injective plus surjective. So if it's both, it's bijective. And we said if a function is bijective, then that gives rise to the existence of an inverse, which we call f to the minus 1. Okay, that's a completely separate function. Okay, we relate it to f because it's the inverse, but we could have just called it g. It's another function, right? So f goes from x to y, f inverse goes from y to x. Different domain, different target, different function. But it's related to f by these two over here. So firstly, it is a left inverse. Why? Because if we start at x, we travel to y, we travel back to x, we end up at the same place. So we call it a left inverse. It's also a right inverse, because if we start from y, we travel to x, we go back to y, and we get to the same place. If it satisfies left and right, we just call it the inverse. Okay, now we're not going to be going on specifically left inverses and right inverses. The inverses we're talking about will always be both, right? We're not going to look at one or the other. Okay, and we had that example with the parabola, right? If we look at the full parabola over the full domain, we had a problem. We went there, we came back, but we ended up at a different point. So we had to restrict the domain. So here we had capital X, that goes from 0 to infinity. We went this way with x squared, 0 to infinity, and then we came back with root y, if we call that y. If we restricted the domain and the target to this, then it was invertible. We didn't have that problem of going there and back and things not working out. So going from x to y, we took x squared, and that worked fine on its domain and its target. Remember, the target is equal to the range, okay, because it's surjective. So if I say target or if I say range, in this case, it's the same thing. You just go back to here. Okay, target equals range. So you can use it interchangeably here. Okay, and then going back, we use root y, and that fixed all of our problems. Okay, and then for homework, I told you to do the same thing with the other branch. Okay, I hope all of you did that. Yes?
So does it matter if you use square root of y or square root of x? Because yesterday you used square root of x.
Oh yeah, square root of x was just to show you which way it goes. But here I'm calling this y, so I can use y. It doesn't matter so much. Okay, I'm just showing you the two different sides. I mean, you can call it whatever you like. You can use t if you want. That's fine. Okay, and then this was for the right-hand branch of the parabola, and then the homework was to do it for the left. Okay, did everyone do the homework? Yeah, okay, cool. So since you all did the homework, what was this function? Coming back. You had to change it. What would that be? You all did the homework. What do we get? Okay, if you haven't done the homework, please do the homework. Okay, the test is coming up, and you will be tested on this stuff. Okay, so I'll leave that for you to try out. Okay, so we're going to do a similar thing, but now with a trig function. Okay, so we're going to try and find the inverse of sine. Okay, so back in high school, you just wrote down sine inverse and arcsine. Right, you just left it at that. But now we're going to look at the domain and the range and see where things go wrong. So we have f of x equals sine x. Okay, we're going to do it the same way as last time. We're going to start off with like a rough guess, see where things go wrong, and refine our answer until we get the right answer. For the test, please do not do it that way. This is just for teaching purposes. For the test, go straight to the right answer. Please do not put the intermediate wrong steps like I'm going to do here. Okay, I'll just think that you don't know what you're doing. Okay, so rough guess, real numbers to real numbers. At the top we have sine x. And we're going to examine what goes wrong and all of that. Okay, so firstly, this needs to be injective and surjective. Here we run into a problem with surjectivity. There's a problem with that. Why? Because the target is all of the real numbers. What's the range? -1 to 1. Well, there's a problem there, because for surjective functions, the range must be equal to the target. So the real numbers as the target, that's no good. We don't want that anymore. So that's wrong. Let's try again. So the real numbers, 2 minus 1 plus 1. Cool. We fixed one problem, now we fix the other problem. This needs to be injective. Currently, it is not injective. It is surjective. We fixed that. Not injective. Okay, so why is it not injective? We could do the whole process of sine A equals sine B, solving it. Doesn't help so much. Instead, we draw a sketch. So, something like this. Okay, if we do that horizontal line test, we see it cuts through a lot of points horizontally. So certainly not injective. How do we fix that? Well, we've already messed with the target, so we can't do much more with that. But we can mess with the domain. We can restrict the sine function to only be on a certain interval, and on that interval, we guarantee it's injective. So let's do that. If we look at 0 to pi, okay, I'm going to start talking in radians. Okay, 0 to pi, or 180, if you want to translate. So 0 to pi, it is not injective, right? Horizontal line test, it cuts here, no good. Okay, we can pick the domain, so I'm just going to pick a few things. Pi to 2 pi, again, it's not injective. Horizontal line test, it cuts here and here, that's no good. Okay, what about minus pi over 2 to pi over 2? Let's see what that looks like. So at minus pi over 2, we're over here. Pi over 2, we're over here. So that's minus pi over 2, or minus 90, if you're still a bit new to that. So minus pi over 2 to pi over 2, we restrict it to that little portion. We get rid of everything else. Is it injective now? Yeah, it is. So let's take from here to be our domain. Because there it is injective. We can choose it, but it's up to us. We could choose from here to here if we wanted to. It's up to us. It's our inverse. We can do what we like. But from here to here, That's kind of nice, so we'll choose that. Okay, so we got to this point. It doesn't work out. So let's write minus pi over 2 to pi over 2. Going this way, we use sine x, and that goes into minus 1 plus 1. And coming back, we use sine inverse. So here we use that minus 1, just like we had with the f. Okay, so name of the function, minus 1, that's inverse. So we can write sine minus 1 x, y, just to not confuse things. Okay, again, you can call it what you like. If you want to call the first set A and the second set B, that's fine. If you want to call it X and Y, that's fine as well. Just be clear with what you're doing. So this is also written as arcsine. It's the same thing. So if you look in the textbook or the notes or online, you might see it like this, or you might see it like this. It means the same thing. Okay. So that's it. That's our inverse. So we have the sine of x restricted to that part of the domain. So that's our new domain. That's our new target. And here we have arcsine. Now let's sketch these two. Okay, so the sine bit, that's going to look like that. Okay, here will be minus pi over 2. And here will be pi over 2. Okay, the x values there. Let's put this, let's put that there. That will be 1, that will be minus 1. Yes? Okay. Okay, so we've got the domain going to the target, and then the functions going either way there. Okay, you good?
What's sine y on the right-hand side? What is that?
Arc, ARC. It's another way of writing inverse. So you can write arc sine, arc cos, arc tan. It means this over there. Okay. Yes.
How do you decide whether you domain or
We went through that here. So the new domain is where it's injective. So like I said, if we go from 0 to pi, it's not injective, so that doesn't help us. If we go from pi to 2 pi, horizontal line test, not injective. Minus pi over 2 to pi over 2, it is injective, so we choose that. Okay. So it's the part of the domain where it satisfies that horizontal line test. Okay. Okay, and then here, so we sketch that bit. What is the inverse going to look like? Now, from high school, you know that the inverses are reflected about that y equals x line, right? If you've got a parabola going like this, the inverse is the root going the other way. Here, it's exactly the same. Okay, we reflect it about the y equals x line, we get the same sort of thing. Okay, so it will look something like that. Okay, rough sketch, right? We just want to look at what it roughly looks like. So here, this will now be minus 1, that will be 1. And the y value, that will be minus pi over 2 to pi over 2. Why did we swap the domain and the range? Well, that's exactly how it's defined. If we go back here, f goes from x to y. F inverse goes the other way around. The target of f is the domain of f inverse, right? The domain of f inverse is the target of f. The target of f inverse is the domain of f, right? They go back and forth like that. So here, this is the domain for f, but it's the target for f inverse. This is the target of f, but it's the domain of f inverse. So here, if we look at the picture, here on the left there, the domain was minus pi over 2 to pi over 2. If we do the swap around the y equals x line, swaps around, so now the domain is minus 1 to 1. And the range goes from minus pi over 2 to pi over 2.
So
Yes?
what function was that?
Sine. Yeah, this is sine. and this is arc sine. But it's sine cut between minus pi over 2 and pi over 2. So please do not draw it past that point, because then it's no longer injective. So it's just that slice. Okay. And whatever we choose for that slice, this one is then determined by that. You know, like that reflection thing that you did. Okay. Everyone okay with this? Okay, so the first thing we did was we fixed up the target, and then we fixed up the domain, and then we get the picture. Okay, that's all you really need to do. Finding the inverse function, for here we just call it arc sine. There's no nice formula for it, so we just call it arc sine. If you have x squared, you do the same thing that you would do in high school. If you have a line, same sort of thing. Okay, so for homework, okay, find the inverse for cos. Okay, now remember, when I say find the inverse, there are three things that we need. Number one, we need the function rule, like f of x. What is f inverse of y? We need the domain, we need the range. So remember, if I just say find the inverse, you need to specify all three things. Okay, don't just give me the function rule, give me the domain and the range. The process for this is exactly the same as sine. Just follow the process exactly the same, you'll get the inverse for that. Okay. Any questions about the homework? Okay. Let's have a look at another problem. Okay, so here I'm going to give you a function and a domain. So I'll give you bits of the information, and then we need to find the rest. Okay, so find the inverse of f of x equals 2x minus 1 with domain minus 1 to 1. Okay, so that's my function. Okay, I've left some stuff out. I've left the target out and the range out, but we can work that out. That's fine. So we got the rule and we got the domain. Everything else, we need to figure out what that's going to be. Okay, so firstly, the target is missing. We need to find that. Then we need to see if there's any issues with the domain and the target, like we had before. And finally, we find f inverse, and that's everything. So, minus 1 to 1 gets mapped into some y that's not given. We need to work that out via f of x equals 2x minus 1. Okay. Now this is just a straight line. We can work out the target quite easily. So, firstly, if we make the target all of the real numbers, is that okay to do? No. Why? It's too much. It won't be surjective. Okay, target's too big. So what we need to do is, instead of thinking about it like the target, remember, for it to be surjective, we need that to be the range. So here's the function. Here's the domain. Let's sketch it and see what the range looks like we did before with functions. You do a rough sketch and you see what the range looks like. Okay, so here 2x minus 1, something like that. Right, I didn't even put points or anything, just rough sketch, just quickly see what it looks like. Okay, positive gradient, shifted down a bit, we got our line. Now the domain is here, minus 1, 1 is somewhere there. Okay, what's the function value at 1? 1, good. Yeah, 2 minus 1. Is it a bit early for you? Okay, and at minus 1? Minus 3. Okay, that was a bit quicker, good. Okay, so the line goes through those points, so the range is everything between them. Right, there's no gaps or anything. So what's the range? Okay, good. Do we include the endpoints? Yes, we do. Right, square brackets there. So we include the endpoints. Okay, so we can fill in what y needs to be. -1 to 1. We can go this way with f of x equals 2x minus 1, minus 3 to 1. Okay, is this injective? Yeah, it's a line. Of course it's injective. Is it surjective? Of course, we made it surjective. Okay, so if it's injective and surjective, it's? And so the inverse exists. How do we find the inverse? Same as we did in high school. So, y equals 2x minus 1. Swap x and y. Okay, we can take the 1 across. Divide by 2. Okay, so that's our inverse there. But this is all side working. This is not part of our calculation. Let's put this in a cloud. This is just side working to give us an idea. So the inverse looks something like that. Okay, y equals half x plus 1. But that's not exactly what the inverse is. F inverse of y, that will be 1/2 y plus 1. Why? Well, because we swapped x and y. We need to swap them back. Okay, so f of x, that was 2x minus 1. F inverse of y is 1/2 y plus 1. Okay, please make sure you get your x's and y's correct. You don't need to use x and y. You can use a and b, s and t, it doesn't matter. But remember that the first function goes from x to y. In this case, the inverse then goes from y to x. They have different domains. They have different targets. They are different functions. Okay, please remember that. Now, our thing's done. Okay, but we can check. We can check if this is correct. How do we check? Well, there's two conditions for this to be an inverse. It needs to be a left inverse and a right inverse. Altogether, it needs to satisfy both of those properties. So, let's just check. Does that actually work? Let's do f of f inverse. What is this going to eat up? Remember composition. This eats up the thing, and that eats up the result. F inverse eats up what? X or Y? Y. There, it's given at the top. F inverse eats up Y. So this is going to be f of f inverse of y. So we're going to take f, and inside f we're going to put f inverse of y. What's f? That's 2x minus 1. So inside that we're going to put 1/2 y plus 1. So that's the x bit. We put that function in there, like we did with composition, and then we need the minus 1. So in the brackets here, that is our x that we've replaced with that composition bit there. Now we just simplify. So the 2.5, that cancels. Y plus 1 minus 1, that's y, check. Okay, we started at y, we ended at y. So that little loop that we did, we started at y, ended at y, that's done. Now we need to check the other way. This just showed that it was a right inverse. We also need to show that it's a left inverse. So the other way around, f inverse after f, this now eats up an x. Why? Because f eats up an x. Okay, please do not mix up your compositions. So this is going to be f inverse of f of x. So whatever the output of f of x is, we put that inside f inverse. So what's f inverse? We had that here. That's 1/2 y plus 1. We're going to take f and we're going to put that inside f inverse. So that's 1/2. Y plus 1, but we're going to replace that with f. That is 2x minus 1. And then we had the plus 1, right? Because it was 2x plus 1. Okay, there we go. That cancels. The minus 1 and the plus 1 go. And we're left with x. Check. We started at x. We ended at x. So we're all good with that. Okay, any questions on this procedure? Okay, so a question for the test that's coming up might be something like, here's a function, here's its domain, find f inverse, and check that it's the inverse. Well, this is how we find the inverse. We know how to do that now. It needs to be injective and surjective. That's how we get the inverse. How do we check if it's the inverse? Well, it needs to be the right inverse, and it needs to be the left inverse. If those two are satisfied, then you've done the question correctly. If you end up with 2x over there, you've done something wrong. Go back and check. Okay. Everyone happy with that? Okay. Let's do some homework problems with that. Okay, find f inverse and check your answer. For the following. Okay, number 1. F of x equals 3x plus 1. Okay, there's the domain. F of x equals, it was minus 2x. Okay, those three for homework. So we have f of x, 3x plus 1, again a straight line. There's the domain. Okay, the target is missing, but that's up to you to find. F of x equals 1 minus 2x, another straight line. There's the domain, the target's missing, that's for you to fill in. And lastly, f of x equals x squared plus x. There's the domain, the target is missing. Please find f inverse for all of those. Yeah.
Could you do an example on this, but for an exponential graph or cube graph?
Yeah, we're getting there. That's just the homework for the line bits. Don't worry. No, it's always good to ask questions. Okay. Next one. Yeah, so I wanted to get all the line stuff done, and then we'll look at some more difficult things. Okay, so now we're looking at f of x equals 2 to the x minus 1. Okay, a little bit more difficult than the straight line. Okay, it's a bit more complicated, but not as complicated as the x squared. Right, for x squared, we got that problem with the surjectivity and the injectivity. For this one, we know it's injective, so that bit's fine. As for the other bits, we need to work on that. Okay, so let's go through the same process. We guess an answer, see what goes wrong, and try to fix it. Again, please don't do that in the test. Just write what the answer should be. Okay, so good guess, real to real, 2 to the x minus 1. Okay, is that a good domain? Yes, it's a good domain. There's no 1 over x, there's no dividing by 0, there's no roots to worry about. Domain's fine. Okay, what about the target? Is the target equal to the range? No, it's not. 2 to the x minus 1 has that horizontal asymptote. So there's problems with that. So a quick sketch of what this looks like is going to be something like that. Okay, rough sketch, right? It doesn't need to be perfect, but we know immediately from the sketch we've got that horizontal asymptote at minus 1. Everything below that, the function never hits those y values. So certainly not surjective. Okay, So minus 1 down, function doesn't exist there. So it's certainly not surjective. So the target and the range is from minus 1 up to infinity, right? Okay, so we can fix the target there. And then it will be both injective and surjective, and then we can find the inverse. Okay, and then we'll see. Maybe there's problems with the domain. But for now, let's fix one thing at a time. Okay, so we have real numbers. Now we're going from minus 1 to infinity. 2 to the x minus 1. Okay, that looks fine. Okay, this is now invertible because it is injective. We knew that from the beginning. And it is now surjective because the range matches the target. So we're all good to find the inverse now. Okay, so this is fine as is. We go on the side and we find the inverse exactly the same way you would do in high school. So we have y equals 2 to the x minus 1. We can do that little swapping of x and y. This swapping of x and y is equivalent to that reflection about y equals x. Right? Okay. So here x equals 2 to the y minus 1. We want to solve for y. So take the 1 across. So x plus 1 equals 2 to the y. Now we want the y to be down. How do we undo exponentiation? Logarithms. Good. See, we knew what the inverse was already, but now we're just being careful about it. So this is log base 2 of x plus 1. Okay. Again, this is all in a little cloud. This is stuff on the side. Right, that's a little side working that we do. Now we can write down the inverse. We know what it looks like functionally, but what does it look like in our case? So f of x, that was 2 to the x minus 1. We know the domain and range. We'll look at that now. F inverse now eats up a y. That's going to be log base 2 y plus 1. So again, that's why I put it in the cloud. Here, this is y of x, right? But this needs to eat up a y. So we've swapped x and y. You need to put it back. You can't just swap it and leave it. You need to. So you can say swap x and y, and then again swap x and y to put it back. Okay, don't just do it once. Okay, so we've got this. What about the domain and range of this? Does it fit with what we have? Okay, this, ignore the plus 1, a normal log plot. What does that look like? It looks something like this. Right? Everyone knows what a log looks like? Okay. We've got this vertical asymptote at the y-axis. Okay, so it doesn't pass through the asymptote. What's the range? Minus infinity to infinity. Right, no bounds for that. Okay, but that's just a log. This is log plus 1. So it shifted to the left. So we shift it. So it looks something like that. And that point is now minus 1. The asymptote was at 0. We shifted it to the left by 1. So the asymptote is now at minus 1. What's the range? So we did the range, sorry. What's the domain for this? Negative 1 to infinity. The range was all the real numbers. And the domain is negative 1 to infinity. Let's have a look back here and see something interesting. The range of the first function was negative 1 to infinity. What is the domain of our inverse? The log function. Negative 1 to infinity. That's cool. Okay, the domain of 2 to the x minus 1 was all the real numbers. What's the range for the log that we just drew? It works out quite well, so we're done with that. So going back here, we can fold this in. That's log base 2 y plus 1. No problems with the domain and range anymore. Okay, makes sense? Okay, so you see there's two ways of looking at this because these are so related. If we look at the original expression, and we give it a domain and a suitable target, here, that target came from just that function there. We didn't even know what the inverse was, but we went through all the calculation and it came up to be the domain. Okay, so we could find the inverse first. First we find the inverse, and we look at the domain. The domain is -1 to infinity. So this domain must then be that target, because it's the same thing, right? So you can either look at it as f first, find what the target should be, or you can find f inverse and look at its domain. It is the same thing. So this set here, this is the target of f. It is also the domain of f inverse. You can look at it two different ways. You are working out exactly the same thing. You can either look at the function f and find out what its target is, or you can find f inverse and find what its domain is. It's the same thing. You're doing exactly the same work. Okay. And then finding the domain, either it's given or you need to work it out. Remember, we don't want to divide by 0. We don't want to take the root of a negative. You know what to do for that. Okay, everyone okay with this example? Okay, let's look at, so I did the cos one, that will be for homework. We're going to do the tan one here. Okay, and then one more funny looking one. Okay, so here we have f of x is equal to tan x. Okay, that's it. I'm not giving the domain, I'm not giving the target. That's the function. We need to find everything else ourselves. So, what do? We have a guess and see where that guess goes wrong and figure things out from there. So, let's say we go from the reals to the reals via tan x. Okay. Now we know what tan x looks like, right? It's something like this. Right, and then that's repeated every 180. So I'm just drawing the one bit there. Okay, is it injective? It's not, because this is repeated, right? It looks like that when we repeat it. If we do a horizontal line test, it cuts through a lot of points, so it's certainly not injective. So we need to fix the domain so that it is injective. That's the first thing. Second thing, is it surjective? Who says no? Hands up. Okay, why do you say no? Put you on the spot there. Why do you say no? No, it's good to think about it. So remember the definition for surjective. We don't leave anything out in the target. Yeah. No, asymptote has nothing to do with it. No, asymptote is domain. Asymptote is where x values are left out. Okay, look at the y-axis. Do we reach minus infinity? Do we reach 0? Tan of 0, 0. Do we reach infinity? Is there anything left out along the way? It must be surjective. Asymptotes, that's a domain problem. So we go from minus infinity, think of this line here, minus infinity, we go all the way up through 0, all the way to infinity. No gaps along the way, we cover everything, it's surjective. So that means the target can be real numbers, that's fine. We have a problem with the domain though, because of that injectivity. So let's draw this a bit nicer, and then we can see about that injective behavior. Okay, I'm only drawing the positive bit, that's all we really need. Okay, remember tan is repeating as we go along. So this section here is repeated here and here and here and here. In the negative direction it's also repeating. We don't need all that repetition. Let's just take one of them. We can take this one, we can take this one or this one or this one, doesn't matter. Same thing with the sine function. It's repeating. We just took one section. So here we're also going to take one section. We're going to take this one because why not? Okay, so what is that section? Here is going to be minus pi over 2. Here is going to be pi over 2. Right, 90, that's where that asymptote is. So that asymptote divides up our sections. So if you want to take one section, it's from minus pi over 2 to pi over 2. If you wanted to take this other section, it would be pi over 2 and then plus pi, because it takes up 180. Okay, so that's our domain. One section of that tan function goes from minus pi over 2 to pi over 2. So we choose that to be our domain. You could choose the other one. That's perfectly fine. I'm going to choose this one. Okay, it's all how you define it. This is our inverse that we're making. Okay, so that bit was a problem because of injectivity. So now we're going to have minus pi over 2 to pi over 2. Going this way to the real numbers with tan of x. And coming back, we're going to use arctan of y. That's our x, that's our y. Okay, is it surjective? No, it is surjective. There's the domain. It's one tan section, horizontal line test. It only cuts 1 point. It's injective. Is it surjective? So it's bijective. So the inverse exists. We can write it down. This is its domain. That is the range. What does the inverse look like? Well, we can sketch it. We know what tan looks like. We just flip across y equals x line. We've got tan inverse. So let's just draw tan here. Looks like this. Asymptote there. Asymptote there. That's at pi over 2. That's at minus pi over 2. It goes up to infinity. And it goes down to minus infinity there. That's tan. Now just flip it over in your head and we get arctan, and it's going to look like this. You see, I flipped it over. Does everyone see that? Who does not see that? Everyone sees it. That's fine. Okay, you're going to be sketching these, so if you don't see it, please let me know. Okay, so we've got this. Now the domain will be minus infinity to infinity. Why? Well, that target was minus infinity to infinity, so this domain is minus infinity to infinity. What about the range? So here we've got an asymptote here, we've got an asymptote there. Why do we have horizontal asymptotes? Well, they were vertical, but we flipped it, so now it's horizontal. And this goes minus pi over 2, pi over 2. Okay, and that's it. We found everything we need. We were given the function. We found a suitable domain and target. We found f inverse, again with a suitable domain and target. Now that's everything that we need to do. Okay. Everyone okay with that? Okay, yes?
Those are asymptotes, then why are we using them? Why do we use square brackets?
Where's the... Oh, sorry, that was supposed to be round brackets. Thanks for that. Yeah, this was supposed to be round. Okay. Cool, thanks for pointing that out. Okay, yeah, so round brackets because the asymptotes we don't include. Okay, good. Okay, besides that, any other questions? Okay, good. Let's have a look at one more example here. Okay, so we've covered polynomial stuff, we've covered lines, trig functions. The next thing is those hyperbolas. Okay, so let's say f of x is equal to 1 over x minus 1 plus 2. Okay, standard hyperbola. Let's see what the domain and range needs to be. Let's see what the inverse function looks like. Okay, as with all of these examples, we start with the real numbers to the real numbers and see what goes wrong. Okay, so there are two things we can spot immediately with this. Number one, we are dividing by something, so there's a problem with the domain. And number 2, we've got that asymptote there, so there's a problem with the range. Okay, so let's fix those. Let's first fix the problem with the domain. We can't take all of the real numbers. What needs to be excluded? 1. Good. So can't do that. So we'll have minus infinity to 1, union 1 to infinity. Okay, good. Now the range, there was a problem with that. What do we need to exclude? 2. Good. So it'll be minus infinity to 2, 2 to infinity. Okay, good. So, is the hyperbola injective? Picture it in your head, draw a horizontal line. Does it cut 2 points? No, it just cuts 1. So it's injective. Is it surjective? Yes, goes minus infinity to infinity. We leave out 2, but that's fine. That was never part of it anyway. Okay, so it's injective, it's surjective, it's bijective. We can find the inverse. So, y equals, what did we have here? 1 over x minus 1 plus 2. We do the little swap with x and y. So, x is 1 over y minus 1 plus 2. Now we want to solve for y. So we'll do that quickly. X minus 2 equals 1 over y minus 1. You can just flip both sides quick. So 1 over x minus 2 is equal to y minus 1. Can add 1 on the other side there. Y is equal to 1 over x minus 2 plus 1. Very interesting. The inverse of a hyperbola is another hyperbola. Okay, that's something interesting. Okay, so f of x, this was 1 over x minus 1 plus 2. F inverse of y, that's going to be 1 over y minus 2 plus 1. Okay, we've done everything, so let's just do a quick recap here. What's the domain of this? Just look, where's the problem? We don't want the problem. Everything except 2. Let's look at the range for the first function. Everything except 2. We get that there. So f inverse going this way, that's the domain for f inverse. We found it already by looking at the range of f. Okay, quickly looking at this. What's the range? Everything except 1. Let's look at the range over here. Everything except 1. So you see, we found the domain and the range just by looking at f. We could have done this the other way around. We could have found f inverse first and then filled in the sets. Or you fill in the sets and then find f inverse. Okay, they're so related to each other, you can do either method. Okay, any questions? Okay, so the method, straightforward. You need to find the domain and the range such that it is injective and surjective. Find f inverse exactly like how you would do it in high school. And that's it. Okay.